right, another question comes in, number 9 and 11 on that exact same worksheet 45-46. This is the other way to do it, right? There's one way, the augmented matrix and the REF and the RREF and all kind of fun math and the way I did it back in my day. But there's another way, there's inverse matrices. Now that kind of feels more like this. It feels more like if you had 5x equals 15 and you guys were like, ooh, I want to divide by 5 or multiply by 1/5 on both sides, right? You would do the same thing on both sides, and then you'd get x equals 3 and you would jump up and down. That's the logic behind inverse matrix. So the way you set it up, number 9 says just set it up. They want what they call the coefficient matrix. So just give me the coefficients. So put the x's, put the y's, put your variable matrix, x and y, and then put your constant matrix. And that's it. That's like rewriting the equation in matrix form. That's like this step. We're just writing the equation. So taking some data and making an equation out of it. Now, the fun part would be, notice what we did in this next step. I multiplied by the inverse, right? Now, that's important in matrices. When you multiply by the inverse, you have to do it. The order matters. So if you did the inverse matrix first and then the other matrix, that has to be consistent on both sides. You can't be careless and do it in any order you want. That's not how matrices work. They're specific to the way they multiply. So be super careful. So what does that mean? Let's do number 11. So we're going to set it up just like we did number 9. We're going to go, all right, -6, -5, 2, 5, xy, and then we're going to say equals -11 and 7, and there it is. It's set up in a matrix. Now the fun part. I will call this matrix A, right? And I'll call this matrix B. And this one I don't care about because that's a variable matrix. That's what our answers are going to be. I want to move this one, A, to the other side, but I can't. That's no division. But I can multiply by the inverse. Now notice the inverse is on the left, right? So when you multiply those two things together, the inverse has to be on the left. So be consistent. The inverse has to be on the left over here also. So all that means is I'm going to get x and y, but I'm going to need the inverse, and then I'm going to need matrix B. In fact, I probably want to give myself a little bit of room. So here's x and y. Now, how do you find the inverse of a matrix? Not a big deal. You multiply this way, you get -30. You multiply this way, you get -10, and you do bottom minus top. So -30 plus 10 is -20. So 1 over -20 times the old switcheroo. 5 and -6 get up and switch spots. Then that -5 gets a sign change, and that 2 gets a sign change. And there's the old switcheroo. Now, what does that get multiplied to? -11, 7. So good thing we learned how to find inverses and how to do multiplication. Now you can distribute the 1/20th if you want, but that is going to make the math kind of gross. So I'll save it for the end. So if I multiply here, I get -55 and 35, right? 5 times -11, 5 times 7, and I add them together. That looks to me like -20. So this is going to be -20. And then I do the same thing with the second row in that first column. I'm going to do -2 times -11 is 22, and -6 and 7 is -42, and I'm going to add that together and get -20 again. Cray, cray. And now look at that. I have x and y. You probably already see the answer. -1/20th. Whoops, not 1/20th. -1 over 20. Multiplied to -20, -20. Good thing we did scalar multiplication, way back when. We get 1, 1. So there it is, x and y, 1, 1. Now guess what? I could do this on a calculator too, and I'll show you that in like a minute. Stay happy.